So that was kind of it on MongoDB, but what I want to go into now, I want to talk about how we can actually, right, what's the big thing we're talking about? How to build backends for mobile applications. So I just talked about MongoDB, how whether or not you build the rest of the system yourself, basically as a database technology, it's got some things that make it an attractive replacement to NoSQL. What I want to talk to you about now is, and give you a little demo of, and so this will actually let you see some of MongoDB, is MongoLab. This is the hosted MongoDB service that my company runs. And basically, the way I like to think about it, at least in the context of mobile, and the way we've been talking about mobile, it's basically the EC2 hosting plus the MongoDB plus the REST API with admin tools all packaged into one. And basically, there's kind of two ways folks are using our hosted DB service, and we're in private beta right now. I'd encourage you guys. At the end, I'll give you information on how you can try us out. But basically, there are two ways. You go online, you create a Mongo database. We host it for you in the cloud. You can connect to it from your own application. So we give you connection info, and I'll actually show you in the demo. It'll be a lot more clear once I get into the demo. But once you create your database in the cloud with our service, let's say you've got a Ruby on Rails application. We'll give you connection info, host and port. You can connect to it via the MongoDB drivers, or, and this is something that's really attractive for the mobile folks, we actually have a REST API on top of MongoDB. That's part of our service that you can use from your mobile phone to talk directly to the database. OK, so here's my slide about the API. So basically, this is the API. And I'm going to actually show it to you in use so you can see it actually working. But it's really simple and really powerful. Basically, I'll just go through it really quickly. With a GET, you can get at these are the databases linked to your account. So you go online, you create an account, you create a database. You can see all the collections of a particular database. You can see all of the, this is how you can see all of the documents or objects in a particular collection. Right? This would be show me all the posts, let's say, all the blog posts. Using post, this is how you put new stuff in a collection. Right? So you post a JSON object to that collection, a new guy's in there. This is how you look at a particular one. This is using that underscore ID, like you had asked about. So everything has an ID. So this is the way you can uniquely point at everything. Get gets it to you. Put allows you to modify it. Delete obviously deletes it. And then we support the full query language. So the full query language with all the craziness you got in there. This is something I didn't show you before, but it's a way of restricting. This is also part of MongoDB. This is like the projection clause in SQL. This is how you strip out fields that you don't care about looking at in the result. You can sort, and then the skip and limit. These guys are used together to implement pagination style things, right? Like skip 20, give me 10. That's the second page. And using this, you'd be surprised. You can do a lot. So what I wanted to do, actually, is I wanted to, actually, I'll sit down now. I wanted to do a demo for you guys where we implement a little simple location-based application right here. Well, at least the server side of it. I'm not going to do the phone side of it. But basically, the idea here is a little geopost application. So let's say we want to build an app where you can just walk around town with your Android phone, and you can, anywhere you go, you can just post a note to a particular place and time. So we could, for example, post notes here. Oh, this is a really cool talk. Will is really awesome. That kind of thing. And let's say we wanted the post to have email, date, message, location. And let's say we just wanted to do two things. Adding a new post and get me all the posts near me. Right? Seems reasonable. So this would be our design, right? How do I add a new one? Remember, I was showing you the API. So this is how we would create a new posting. Here, where we actually post the latitude and longitude, this we'd get from the phone. So you build your UI, you'd let people would fill this stuff in. This you'd get from the phone, and you do a post to the geopost collection. And this is how you would get all of the posts near me using the geospatial search stuff. You'd use the REST API. You'd specify a query where the location is near. You give this is San Francisco right here. Question is, how does the system know that this is a location to do geospatial indexing on this particular field? And the way it knows is you actually create. So in the part of the API where you can create indexes, you can specify that an index is geospatial. So what you do is you create an index. And actually, I'm going to show you. We're going to do it in the demo. I'm going to create this bad boy from scratch. But basically, it's when you specify the index on it. And actually, this is the one exception. Remember I told you you can search on anything if it doesn't have, even if it doesn't have an index, but not these. You need to tell it that this is a latitude longitude pair. So this is MongoLab. I actually already created the account, but you can go on and create an account. Well, we're in private beta right now, so it's free. And we're still working on our pricing plan. But, I think it's going to probably end up being something where, for the site, it's probably going to end up being a tiered thing, and it's going to be based on memory usage, or storage use, actually, in particular. So there'll probably be like a small free one, and then stepping up, this much storage, this much storage, this much storage, and then maybe afterwards, like getting past some ridiculous size, like making it metered on that. So we're still working on it though. But that's one of the things one of the reasons we're looking for beta customers is to get some feedback from folks as to, how they plan on using it and stuff like that, so we can do the pricing right. Okay, so when you create an account, basically there are no databases. So we're going to create a database. I'm going to call it the demo database. I'm going to add a user. You don't have to do this now, but I'm going to. This is a database user. So I'm also, as I create this database, I'm creating a database user for this hosted database. So here it is. I can go in there. You immediately get the connection info you need to connect to that database from your app. For those of you familiar with MongoDB, this is the typical information you need. I can create other users for the database right here. So if you wanted there to be other database users, this is where you would do it. We're just going to have one because that's all we need. There's also a page that shows you statistics on your database. Let's make a collection for the geoposts. Okay. So we've made the geopost collection. I'm going to go in here. I am going to create that index that we talked about. So as you can see, actually, the system created an index on ID by default. We're going to add another one. We're going to actually add a geospatial index to, I happen to know location is going to be the name of the field we're going to use, so I'm just going to do that now. Okay, great. So we have our collection. It has nothing in it. Let me now, okay. So now let me show you. I've actually created some seed data. So actually, just to make it more readable and save me typing, I've taken out the date and I've taken out the email. So basically just messages and latitude, longitude pairs. So what I'm going to do now, I'm going to use a tool. This is a MongoDB called Mongo Import. Oh. Okay. Oh wait. Yeah. Okay, cool. So that's Mongo Import. Can everyone see this? We're going to import that file because I want to seed this with some data before I show you how we use the REST API.
Can you import through the web?
No, actually, we do not have. The API does not support bulk import with the API, but yet. But what we can do is we can still use. I'm going to use this connection info here. So I'm going to do Mongo import -h. I'm going to copy and paste this. OK, great. So that's my guy. I'm going to supply username and password. And I created this when I created the database. Remember when I created it, I made a username Will. So I'm going to import to there. I'm going to say that the database is demo. The collection is geo posts. And the file is that file I was just showing you. All right, baby, let's see if this works. OK, well, here they are. So this is another instance I had when I was working on the demo. So basically, if the import had worked and I was able to connect, you'd have a bunch of geo posts in here, one for Cleveland, San Francisco, Chicago, what have you. So this is the general technique you would take. So let me just back up and say where we are in this. We're basically implementing the back end of the app using this design. And the basic design is we create a collection that's going to store our posts. We use HTTP post, the REST method, to post JSON objects to that collection. The information here, in this example, I've just filled it all in. But if you were writing an app, this is something that might come from, somebody fills this in on the phone. Somebody also types in the message. The date would probably just be something you just kind of auto-generate as it's happening to get a timestamp for now. And then here, you would use whatever the package is, I forget, in Android to get you the latitude and longitude. And you would plop them in there, post the object, and then it would show up. It would show up right.
So the URL to your post, that's where the information is stored for that object?
So basically, what happens is you'll get an object like this in the database. You'll get we didn't specify IDs, so you got auto-generated IDs, and then this location's in there. And then because I created that index a second ago, as these are getting inserted behind the scenes, MongoDB is indexing these by latitude and longitude. So real quick, so now we have a bunch of these guys, right? Let me show you real quick what it would look like to be dealing with the API. One thing we've provided with our service is the ability to look at what the API would look like from wherever you are in the application. And I want to just make sure I explain this well, because last time I gave this as a demo, I think I confused people. I'm clicking on the View API here. This is another part of our admin tool that gives you an API view on top of the data. So right now, we're looking at the GeoPost collection. We're looking at what the HTTP GET from that is. And oh, can we see that? Yeah, I'm going to get to some. Actually, I'm going to get to something lighter in a second. If you click View Raw JSON, this is these are all the posts. They're not pretty printed. This is exactly what your phone would get from the API when it asks for all of the postings. But what we've done here is this burns your eyes. This is hard to look at. So we pretty printed here. That's all this is. But what I'm going to show you now, right? So we have 13 cities in here. I'm going to show you now how we would create. I'm going to show you how we're going to create a new one using the API. OK, we're almost there. I mean, I can show you here. I can show you real quick. We can also do queries with the API. So for example, I can do something like that, and these are getting me everything in sorted order. Everything near San Francisco. So San Francisco, Los Angeles, San Diego, Salt Lake City. So, and again, this is just using the API, using the query language. But what I'm going to do here is I'm going to show you. I'm going to use curl for this example, actually. Curl is a Linux command line tool for doing HTTP. And it's kind of often used to test and demonstrate REST stuff. Let me just. So here's an example of us. Sorry. Let's see if this works here. Okay, so this was an iful, but really what I did here, this is exactly, basically I just did it the command line. I did this, okay? I said curl, blah, blah, blah. I gave it the whole URL. I gave it the API key, and then I put in Los Angeles and posted it to the collection. And if I hit reload here, we should have another one. Or, no, whoops, not that one. Sorry. Here we go. We should have, well, let me see how many we have here. This has the count, 14. Great. LA was added somewhere. Los Angeles was added. And now, if I go back and for example, I can go back and do this one again here. Oh. Remember last time I put a query on here to say get me everything near San Francisco, and now Los Angeles is the second closest thing, whereas it was San Diego. And then if you were to view the raw JSON, again, this is what would come back to the phone. And so basically, we've implemented, you may not have realized it, but we actually just implemented the entire back end of this application using a cloud-based service on top of MongoDB. Obviously, you could have an app where the back end is really, really complicated, and there's no way you could possibly use something like this. But you'd be surprised how much of your mobile back end it might just be CRUD, right? User profiles, doing geolocation stuff like this. I've seen people do little mini content management systems where it's just little objects representing the content they want people to see, and they're constantly pulling. Configuration, I know from the iPhone folks, the amount of time, like the expectation that your users get your updates to your code and download your app, the updates to your app again and again, just doesn't happen, right? So the more configuration you can put on the server side, and cache it, of course, but the more you can call up the server and say, hey, how should I display this? Are there any new information for the day? Whatever it is, right? Putting stuff on the server side is a really good idea. So real quick, just let me show you what you do on the Android side. I'm not an Android expert, but these are the two packages that are at the core of implementing the client side for this. You've got your JSON parser. This comes in the SDK, and the HTTP libraries from Apache. Basically, this is an example of a GET. You'd make a new client. You'd make a new request. You'd ask the client to execute the GET request. This URL would be the MongoLab URL with the API key and everything. Or, if you implemented your own REST API, it would be the URL for your own API. And then boom, boom, pull the JSON out of the response stream, pass it to the JSON parser. You have your JSON object, and then from there, do what you got to do. Obviously, you got to build the UI and all that type of stuff, but that's the basic idea. OK, so that's, for more info, MongoDB 10gen, this is their stuff. For us, MongoLab, we're in private beta right now. We'd love accounts. Try it out. We're really looking for people to help shape our service, and the more feedback we get, the better. This is our info, and if there's any questions, just let's have a free-for-all, and I'll answer them. And I'll repeat them first, and then I'll answer them. Great. So the question is, how does MongoDB compare to Cassandra? Cassandra is considered a more traditional key value store. So I would say that Cassandra and MongoDB are similar in the sense that they both solve that horizontal scalability problem. They both allow you to create these big clusters of lots of nodes, and they do MapReduce, and they do all that type of stuff. The reason I like MongoDB more is the document model versus the key value model. So the key value model is really just, key and a value. And, you could, I think in Cassandra you can put whatever you want there, right? So you could put JSON there. But it's really not part of the core abstraction that they use. So, JSON is basically just a generalized key value, right? The values are not just objects, but they can be arrays, they can be lists, they can be dates, they can be strings. And the query technology knows that you can say, person.address.zip equals this. And it understands that structure. So to me, Cassandra is a little bit lower level in the technology stack. The abstraction level it gives you is a little bit lower. The document model, in my opinion, is a little bit richer. That's basically, but I think they both solve that. In terms of petabytes and petabytes and petabytes of data, I think they both solve that problem. So the question is, isn't the biggest competition for this Google App Engine or Google Apps? I've tooled around a little bit with Google App Engine. They have you use BigTable, as far as I know. I don't know if they're planning on offering anyone. If anyone else knows, please chime in. I don't know what other persistence mechanisms they offer besides BigTable. So the comparison to BigTable is, I would say, first of all, one's open source, one's not. BigTable is a little bit more like Cassandra, in the sense that it's actually a column-oriented database. So everything's based on indexes.
They have a little bit of internal structure.
Yeah. But the structure, in my opinion, is more like key value of primitives and simple types.
Collections.
Yeah, versus, and they do have collections, they do. But the recursive nestability of collections of lists of objects of lists of collections of lists of lists of lists, not quite what these guys are. Some people care about the open source thing versus the not. But I will say I don't have a huge amount of experience with using BigTable and Google App Engine. But Google App Engine is pretty cool. I did write a little Hello World app on it, and it was cool. And it provides a lot. It's not just it also provides the runtime. So either the Python runtime or the Java runtime, the load balancing. So kind of Amazon has the elastic load balancing stuff. Google App Engine kind of has it built in, a little bit more app awareness. So it's definitely cool. You can use Google App Engine and use this. You could choose to use Google App Engine for your Java engine or your Python engine and all of the libraries there, but also, let's say I want to use MongoDB as my backing store and do that. That's up to you. Yeah, so there are two types of customers. Oh, so the question is, what do I expect the demand to be for MongoLab? Two types of customers. Actually, right now, many more people are using it not for the mobile case, just as a hosted MongoDB provider. And we're not the only ones out there for that. There are two others out there. One company called MongoHQ, one company called Mongo Machine. We think we have a better product, but basically that's just Mongo hosting. And people use it for that. And I expect that to basically grow with the demand for MongoDB in general. I'd say there's always going to be a certain percentage of people who use MongoDB for which a hosted cloud solution is the right solution for them. And that has nothing to do with mobile. They'll write their app on their app server. They'll use MongoDB as a backend. Bam. Then what I'm trying to do by talking to folks like you and by going to these mobile groups is get people to use this in the mobile context, because I think that the combination of MongoDB plus the REST API, we're the only cloud provider of Mongo that actually has an API. And so I just think it's a great mobile solution. And I'm hoping to actually get a larger percentage of our folks doing it for mobile apps as well. The question is do we have different levels of service depending on, see if I paraphrase this right, the read-write profile or mix of the application. We don't plan to do anything like that off the bat. We're going to wait and see if that seems to be a characteristic of an application that deserves some sort of first-class notion in the way we price and in the way we build our infrastructure. But we're going to try to, we're kind of going with keep it simple and kind of optimize later. So right now the answer is no. Oh, so what's the performance difference between read and writes with Mongo? Really depends on the indexes. So for example, if you're inserting to a collection with no indexes, which you can do, you can even take the index off ID because write performance is so important to you. And you can set up your driver to write in an asynchronous mode, meaning it's fire and forget. It's going to write, and it's not even going to really care about the response, or it's going to check later, you can get ridiculous write performance. In fact, some folks are using this for logging instead of a file system. And when you turn off indexing and you turn off getting a response from the server and you make it all asynchronous, just for logs, because who cares if you drop a log message, right? People are getting the same performance as writing to the file system, literally. But if you on the flip side, if you have a collection that has 7 indexes, and like every time you write, you're putting that object into the index and trying to find its home, and that's going to be slow. And then read's a little more stable, or at least read on. Well, let me talk about read. Reading when you hit an index, very fast. Reading when you're pulling a sorted range. The way they do indexes with sorted B trees. So if you're pulling from November 1st to December 1st, and your index is on date, pulling that range will be fast. But then a query that misses an index and is just kind of scanning the set, slower. Sure. Okay. Makes total sense. So the question is, when would you want to use a service like MongoLab, which is basically prepackaged API access to a backing store where you're talking directly from your phone through that API to the backing store, versus building your own, server-side technology where you're implementing the API, you're implementing a lot of business logic on that server-side stack that's in between your phone and the database. And my short answer is to say, if you can get away with simple CRUD, creating objects, reading them, where reading them involves that query language, and that query language can support you, right? Where you can implement the functionality of your application without needing to write your own business logic and middle layer. I'd say things like what we just did, or things where you have, let's say, simple user profiles. I have one guy who's using this to just log stuff off the phone. So he's logging messages, things that are happening with the user and stuff. He's doing a little bit of user tracking and also sending the error messages off the phone. That's a simple inserts. He didn't, writing his own backend. But then, obviously, if you have that business logic, right? So if you were going, this is the other extreme. If you're implementing Twitter from the start today, right? There's no way you'd implement Twitter on something like this. This is way too complicated. Or Facebook or something like that, where there is a large business logic need. So it's really, I think it's on a case-by-case basis, but if I was to try to put it into a box and label what cases are good and what cases are bad, it's when you can use CRUD directly. Does CRUD mean something to everybody? That acronym, create, read, update, delete? That's the way I'd try to coarsely label it, but it's really, you'd have to kind of think about it on a case-by-case. Is that kind of? Okay. So another security question, how we handle security, and I'll talk about it maybe in a little bit more detail. So the way the system is, you're running on EC2. There are several Mongo database servers running. Each one of those Mongo database servers, those are our servers that host the databases for our customers. Those servers are run in what's called auth mode, which is something that is provided by the database itself, meaning nobody can connect to any of the database ports without authenticating. So first thing we do is we run in auth mode. When you go online and you use our service to create a database, you're not creating a separate server instance that's just for you. That's something we want to do in the future, but you're basically getting a database on a shared Mongo server. So you are using that server with other folks. So for example, if somebody ran a query that made that thing go nuts, right? That will affect you. So if you need a private server, that's something we're going to offer down the road. But right now, you're getting very cheap shared instances. You're partitioned from other users based on the way MongoDB does the partitioning, which is it's a separate part of the file system, and it's guarded by authentication. Then that port is now that port's open on EC2. If you talk to that port via a driver from an application you write within EC2, you're going to be connecting with authentication mode, and the protocol's in the clear, though. So on EC2, you're safe because I don't know how many people have used EC2, but EC2 prevents man-in-the-middle attacks through fancy stuff. So you don't have to worry about internal network traffic on EC2. What you do have to worry about is if you want to connect to the database, not over the API, but through the database port over the network. That is not secure.
Right.
So
Whatever the API
Oh, I'll get to that. So that's not secure except for the authentication. So you have to authenticate so people can't connect to it, but they can see the traffic on the World Wide Web. The API is all over HTTPS and uses an API key. So I can show you here, every user to this account, actually here it is, every user to the account gets an API key. So what you do is, if you were writing your Android app, that API key would be something you had to present that from your application in order to gain access to this. Okay, the question is, can we expand the API to have API keys for the end users? I don't really see the need in that per se right now. It's something that you could implement. Like somebody using our database could implement that, at a higher level. But we're really trying to get away from like features that allow other people to do kind of multi-tenancy type things. Like this key is not meant to be a user key. Like if you wanted to implement user security, you'd create a table in MongoDB called user, and then you'd create usernames and passwords within there. Like kind of the same way as like if you were to get Oracle and you wanted to implement a user table in Oracle, like you do the authentication and user management yourself. So right now, I'd love to talk to you more about use cases that you think might be useful there, but I don't see off the top of my head why we'd want to expose the API key stuff to the users directly. Yeah, okay, good question. He's saying if I want to write an app that's got different users and I want to make their data private, the way I would do that, so the way I would do that is the app has a user table that has, let's say, a username and password. Don't store the password, so do an MD5 encryption of the password. So when the person first logs in, they create a username, they create a password, you one-way encrypt the password into that table, and then every time they want to authenticate again, you do the one-way encryption, and then you attach in your the way you design your database for Mongo, you actually just attach, so for example, let's say everyone has a grocery list, and so it's my grocery list app. You would actually, in your own data model, you'd associate the list of groceries with that user, and you would write in your app code, you'd have to code it so that people can't get access to other people's grocery lists. So when somebody logs in, your app would have to honor. Same way, when you're writing like a server-side Ruby on Rails app, somebody logs in and creates a session on the Ruby on Rails app or a J2E app. It's up to you, the guy writing the Ruby code or the Java code. So when you query the database, you say, and user ID is 55, the user that's logged in, versus showing them the other stuff. So the question was, the gentleman was commenting on how I mentioned that you might represent this as an array of strings for a grocery list, and asking whether or not you could have grocery objects instead of just strings. And yeah, the answer is yes. So in my example, I tried to give an example of this. So field values can be not just primitives, but whole nested things. So, and here's an example, comments. Comments are not a list of strings. Comments are lists of comment objects. So this is how you might have a grocery list as a collection, or sorry, not a collection, an array of grocery list objects where maybe it had, the item and how badly I want it, and I don't know, it's the price and some other metadata about that stuff. You could do that. It's not. What do you say? It's not third normal form. You could put this in another collection if you wanted to, and then have references here, saying pointer, the IDs of the objects in another collection. You could do that as well. The question is, can you talk HTTPS to the MongoLab server for the API? You can only talk HTTPS. The question was, can I make my arrays in here as long as I want, basically, right? From open curly here to close curly on the top level, you have 4 megs. It's actually an arbitrary limit just to prevent what people think of as bad schema design. So if you think that list is going to get you over that limit, it's probably you should rethink how you're doing your schema design and maybe put that list of things into a separate collection and maintain a list of references here, or in that separate collection have pointers back out. It really depends exactly what you're thinking, and we could talk about all the pros and cons of like the different design choices. But definitely, like I noticed when I first started using MongoDB, the exercise of schema design was a little bit different than what I was used to in the past. And it's similar in the sense that you think through your problem and you think about how you want to structure things, how you're going to query, and all that type of stuff, and you do your schema design, this is a little bit different, but it's the same kind of thing. There are pros and cons of breaking things out into different collections, embedding, and whatnot. Great question. So binary data, when I was mentioning GridFS and how you can store, the question is how do you deal with binary data? I was talking about how you can store large binary files, but if there's a 4 megabyte limit, how do you deal with that? So the way MongoDB does is they chunk, so big binary files, they chunk up. So if you were to put a 5 gig file in there, they would chunk it up into little binary documents with some metadata about where they are in the ordering. And then when you ask the interface to pull it back out, it just resequences it and gives you a stream that is the full file. So the question is, how does storing and retrieving binary data work? Basically, there's this one key to it. So the binary blob has an ID. And so it's a similar API to how you insert objects. But basically, it's got a stream API. So either from the driver or from the shell, you've actually got from the shell, you actually got to give it a file on the file system, and it will put it in for you. From the driver, you're dealing with streams. So, but it's stored against an ID, and then it's more kind of opaque and abstract than this. And with the driver, then you say, get me the document, or sorry, get me the binary chunk. With this ID, you get a stream, and then you read it or write it. So if they're on, so the question is, what's the performance like between the app server and the database? If you should be putting your app server, if you want to connect to it from an app server, you should be putting your app server in the same availability zone, and then it's pretty damn fast. So you know how Amazon has basically they have regions, they have availability. So there's like Virginia, Northern California, all these different places. You want to physically locate it close, and then it's going to be on a local network within Amazon. And it's going to be basically as fast as it would be if you got 2 different EC2 instances, a database server and your app server, and purposely put them, it's like part of your account. They'd be on the same availability zone, and they'd be on the local network talking to each other. The only way to get faster is if they're on the same machine. Yeah. And if they're on the same machine, then you don't really have a good failover system probably. Like normally, like you'll put the Tomcat. Like you'll have like a database, you'll have like 6, Tomcats and a load balancer, or 6, Django instances or whatever. So usually you don't have those on the same machine. Sometimes you can put them on the same machine if you're just kind of got a small app going, but you should have pretty good performance if it's on the same local network. Cool.
Thank you.
All right, thanks guys.